here's the picture of concavity. So if you look at the blue part, the graph is below. You see the graph, like this beautiful curve, right? This curve is all below its tangent lines. And what I mean by tangent line is these straight lines. This straight line, tangent line, another tangent line at that point, and another tangent line at that point. So if your graph is below all its tangent lines, we say that graph is concave down in that interval. Well, that's what it means, but whenever I see concave down, I think about the frowny face, like here's my eyes, and that is concave down. Concave down. Okay, and like feeling down. And now the concave up part. If you see this curve and take a look at where its tangent lines are, the tangent lines are below the curve, right? So that makes the curve to sit on these tangent lines. So if that happens, we say that this interval is concave up. It's funny because we found how to find them algebraically first, or using calculus, using the second derivative, but that's what it means in graph. Okay, so if you have my little eyes and if the mouth is like smiling up, I think of this as concave up. Hey, that's what I do. And in the middle is where the concavity changes. Okay, where the middle is where the concavity changes. And this is where the second derivative is 0. This is called the point of what? Inflection. Okay. Alrighty, so this is a difficult example, I think, example 5. I got it because I saw some of these in your homework, so I wanted to give you some similar examples. So let me try my best. It may not be the best video, but I'll do my best, okay? So sketching graphs, sketch graph that possesses the characteristic listed below. Okay, what kind of characteristic does A have? Let me see. F is increasing and concave up on negative infinity to 3. Okay, so what I'm going to do is I'm going to just go ahead and draw a number line and say this is 0, 1, 2, and 3. Hey, maybe I'll fix this. Hold on. Okay. Somewhere on, and they didn't really say the y value of 3. So how about I just plot a point at 3? Okay, this is where the concavity changes. You see that, right? This is where the concavity changes. So I'll say this is my point of inflection, okay? This is my point of inflection. It says F is increasing and concave up. So what does it mean? All right, hold on. Increasing and concave up. Let me sketch a concave up graph first. Concave up is a smiley face, right? Look. Ignore that. This is not part of the graph. It's not the graph yet. But if this is concave up, but is this graph that I just sketched, is it increasing or decreasing? It's actually both, isn't it? Look, it was decreasing up to this point, and then from this point to the right, it is increasing. So when they said find increasing concave up, I only need this interval. Like I only need this piece of the graph. You see what I mean? Because the left of it, this is going down. This is going down. This is decreasing. So if I'm trying to graph a piece of graph that is concave up and increasing, I need half of the smiley face to the right. I don't know if I'm making sense. So what I will do is I will sketch a graph to the left of positive 3. That will look like this. Hold on. It will look like it's coming up like this. Well, this is increasing and concave up. Right? It's going up from left to right, and it is concave up because it's part of the smiley face. I hope that makes sense. All right, how about the second part? It says F is, I do want to underline these so that you can see this was increasing and concave up to the left of 3. Now, next part says it's increasing and concave down. Well, what does concave down look like? Concave down is like this, right? But only half of this graph is increasing from left to right. Only this part of the graph is increasing, and from this midpoint, from the maximum, is going down to the right. So only part that I need is just the left side of this frowny face. So what I will do is I will sketch something like this to the right side of those three, like this. And that looks good to me. That looks good to me. This is the graph. This is F that meets this, that possesses the characteristic listed below. So this is my F. And it doesn't really have to touch x equals 3, right? The 3, 0, but you know, this is a graph. This is not the only graph that will meet this characteristic or description, but oh, I do want to write it. This is increasing and concave down. Okay, I'll do a couple more. Okay, I'll do a couple more. All right, the second one it says G is concave down at 1, 3. So what do you mean concave down at 1, 3? So they're not giving us an interval. We're not talking about from x equals 1 to x equals 6. When they say at 1, 6, this is at a point. So I will go ahead and plot that point. 1 to the right, 1, 2, 3, 4, 5, 6. So concave down at 1, 6. So I'm going to have a frowny face at 1, 6. Now what else? It says next part is concave up at 5, negative 2. So 1, 2, 3, 4, 5, down 2. This is a point where the graph is concave up, which means I'll have a smiling face right here like that. And it has a point of inflection at 3, 2. See, this is so tricky because it almost looked like an interval notation because I use these parentheses. But when they say it, we're talking about points. Okay, so now lastly, they have a point of inflection point at 3, 2. So I'll plot that point. 3 to the right, up 2. This is where the concavity changes. So I'll extend my black graph down and touch the blue point. And I will start my red graph from here. And then you know what? I can just go ahead and sketch a little more to the left and right of it. And this is perfect. This is a graph of G that meets the description. Here's my G. Alrighty. I think I like this one better than the first one. Well, they're about the same thing, aren't they? They're just similar types of problems. Alright, how about I do another one? Oh, wow, look at this. F is positive. What does that mean? That means, I'll write it for you, okay? F is positive. That means the graph is, hold on, instead of the, can I say its graph? Its graph is above the x-axis. That's what it means, right? Because F is positive. The function value is positive. The y value is positive. That means we have a graph that is completely above the x-axis. Here's my x-axis. So this graph is not going down. So I'm just going to be able to graph something up here, right? Not below the x-axis. Now what's next? The second part is saying f prime is negative. What? What does that mean? F prime is negative. I'll write it. F prime is negative. F prime implies f is decreasing, right? The slope is going down. It's going down from left to right. So I know I will have a graph that is going down from left to right. But here's one more thing. I have to pay attention to the last piece of the clue, which says f double prime is 0. Oh my goodness, what does that mean? So it is not the rate of change. Okay, how fast this function is decreasing is not changing. That's what they are saying. Or in other words, the rate of change is constant. Let me try to do this in a different way. How about I try to think about it backward? So what we are saying for the third clue is that the second derivative is 0, right? The second derivative is 0. That's what they gave us. So if you're going backward, because wouldn't that be x to the 0th power? Oh, no. Yeah, x to the... No, that's not right. That's not right. If the second derivative is 0, what does that say about the first derivative? Wouldn't that be a constant function? Wouldn't that be just a number, right? If you take the derivative of a number. See, I told you these ones are a little bit tricky. Derivative of a number is 0, right? So if the second derivative is 0, I know the first derivative, a step before that, was probably just a number. What kind of function has a constant first derivative? Wouldn't that be c times x, a linear function? Because imagine if I give you a random one, let's say that I make up a random function. How about if I say f of x is 5x? What is the first derivative of 5x? That is 5, right? What is the second derivative of that? That is 0. So I think that's what's going on here. That is what's going on here. But just one more thing is that this function has to be decreasing, they said. So instead of 5x, and 5 is completely random. I could have made it like 3x. Or maybe I'll do 2x. If the original function is negative 2x, the first derivative will be negative 2, and the second derivative will be 0. And I think this meets the condition. Only if I sketch this graph above the x-axis. So it's a tricky one. And I'll just say this is my f. This is my f. And I don't think I want to draw an arrow. Why not? Because if I continue going down, wouldn't we eventually touch the x-axis, right? So this is an awkward situation because I'm not allowed to go below the x-axis, but I need to draw a decreasing function, a constantly decreasing function that's not going to go below the x-axis. But it meets the condition. This green piece of graph is meeting the condition if I just keep it this short. If it starts from some point and ends at some point, I'll just say in this interval a to b, this function f meets that condition because, first of all, f is positive, which means it is completely above the x-axis, isn't it? So that's checked off. The second part about f prime being negative, what does that mean? That means it is a decreasing function. It's going down from left to right. It is doing that, isn't it? It's going down from left to right. And lastly, f double prime is 0. And that was the hardest thing for us to think about. But what that means is it's going down at a constant rate. Okay? The rate of change is constant. So I have a linear function, right? The linear function whose rate of change is constant. And in order to kind of think about that, I ended up kind of creating a random function, f of x equals negative 2x. And that's how I was able to picture a function that possesses the characteristics of these three parts. Oh, wow. Okay. It's hard, isn't it? Just thinking about it backward, I think. But anyways, let's do the last part. I don't want to do these anymore. But, you know, I'm doing these because you'll probably see these on your MyLab homework. All right, last one. F is positive. Okay, what does that mean? You do know what that means, which means its graph is above the x-axis, isn't it? Okay, so I'm going to sketch an x-axis. And this graph only has to be above this x-axis. That's what the first part is saying. F prime and F double prime is 0. What does that mean? Let me go ahead and think about one thing at a time, okay? So first of all, F prime of x equals 0 means f is neither increasing or decreasing. It must be a constant function. It's not going up or it's not going down. It's not an increasing or decreasing function. Therefore, it must be a constant function. It's just a horizontal line. So let me go ahead and sketch it. A horizontal line above the x-axis. And let me call this guy x, f. This is my f of x. But will it meet the third condition of f prime being 0? Let me just make up a graph, a function though. What if I call this f of x equals just any number, 2? And it can't be any number, right? It has to be a positive number for it to be positive. So if f of x is 2, what is f prime of x? What is the first derivative? The first derivative is 0. So it meets that condition. What is the second derivative? Well, derivative of 0 is again 0. So it also meets the third condition. So I think we got it. It must be a constant function. It must be a constant function. So I think I will keep this here. An example of f could be this, right? And f can be something else. F can be 3, 4, 5. F can be 1.5. As long as f is positive, because we want it to be above the x-axis, there are several functions, several constant functions that will meet this condition. Wow. Yeah, right? That was fun. So I am done with this lesson. Well, for example 4, I think I just have to do example 6 and that will be it. But hope you are learning, hope you are having fun with this concavity idea.